Hello, ladies and gentlemen, and welcome to the Laws of Exponents. We are going to be reviewing the laws of exponents that you learned in Algebra 1 so that we can take it to the Algebra 2 level in a few days. So we need your thinking caps, you need your pencil, and a notebook so that you can take some notes on these laws of exponents. The first thing we need to know is what are all the parts of this 5 to the third power. So you do need to write this in your notebook. 5 to the third power, the whole thing together, is called a power. The 5 is called the base, and the 3 is called the exponent. Make sure that you write that down in your notebook. We know that 5 to the third means 125. I mean, that's what it evaluates to make, okay? 5 to the third is the exponential form of the number 125. But what we need to know is what does it really mean to be 5 to the third power? Well, 5 to the third power means you have 3 factors of 5, or 5 times 5 times 5. Okay, so the exponent tells you how many factors you have of the base. Okay, so the laws of exponents. The first law is exponential form, and you need to know what the exponential form is. The exponent of a power indicates how many times the base multiplies itself. So if you have x to the n power, the n could be 5, the n could be 20, the n could be 3,000, you would write the base n times, okay? So n factors of x. The exponent is the factors of the base. The n tells you how many times you write the base. So 5 to the third would be 5 times 5 times 5. 7 to the sixth would be 7 times 7 times 7 times 7 times 7 times 7. 6 sevens, okay? So 6 factors of 7. The second law, and you should be writing all these laws down, is multiplying powers. If you are multiplying powers with the same base, you keep the base and you add the exponents. Okay, so example, if you have x to the m power times x to the n power, you will add m and n together. So here's an example in number terms. 2 to the 6 times 2 to the third equals the base 2, and then you add the 6 and the 3 to make 9. And you can evaluate that in your calculator by typing 2 to the 9th power and getting 512. Okay? And how I do this and how I say this is it's all about the base, okay? We don't change the base. It's all about the base. Don't change it, okay? So I get it. When you multiply powers, you add the exponents. Correct, because you do not change the base. You can only change the exponent. Okay, number 3, dividing powers. When dividing powers with the same base, keep the base the same and subtract the exponents. It's all about the base. You can't change it. All right, so if you have x to the m over x to the n, that means you are dividing. You can take the m and subtract the n. So m as in Mary minus n as in Nancy. Okay, here's a real world problem. If you have 2 to the 6th over 2 to the 2, look at here. We didn't change the base, and we subtracted the exponents, and we got 4. 6 minus 2 is 4. And then if you put that in your calculator, you would get 16. Okay? When you divide powers, you subtract the exponents, but you keep the base the same. It's all about the base. You can't change it. It kind of is a little catchy tune, but I can't carry a tune, so I'll stop singing. Sorry. Law number 4, power of a power. if you are rising a power to an exponent, or a power to a power, or an exponent to an exponent, you multiply the exponents. Okay, so if you have x to the m to the n power, you multiply the m and the n. When you have a power to a power, you multiply.
Checking. Okay, I found something on the web for if you have infinity am to the n power.
And even my British Siri recognized my voice. Sorry about that. So when you have a power to a power, you multiply. Kinda, again, a catchy tune. So if you have 5 to the third power to the second power, you would take 3 times 2 and get 6. And then 5 to the sixth is 15,625. Again, we don't change the base. You're not making the base anything but 5. The base of 5 stays the same. So when you take a power to a power, you multiply. Okay, kind of catchy again. Law number 5, the product of laws. Okay, the product law. If a product of a base is powered by the same exponent, then the result is you multiply each individual factors of the product, each powered by the given exponent. Now that seems really complicated, but here's an example. So I have two things being multiplied, and basically what it's saying is that every single exponent on the x and the y get multiplied by the n. So it's kind of like a power to a power and you multiply. You just take each one of these to its individual power. So you could say x to the 1 to the n, a power to a power, and we multiply. And you could say y to the 1 to the n, and it's a power to a power, and we multiply. Now notice these two bases are different, so we do keep them separated. Right, so if you have ab to the second power, you add a to the second power, b to the second power. So when I take a power of a product, two things rather than one, I still multiply every exponent in the inside by the exponent in the outside. So it's still a power to a power, and we multiply. Law 6, the quotient law. If a quotient of the bases is powered by the same exponent, when the result is both a numerator, then the result is both the numerator and the denominator. Each are powered by the given exponent. So this is exactly like the last one, except for we don't have a multiplier, we have a divider. So we have two different bases to the same power, and basically what we're going to say is that if you don't see an exponent, it is a 1. Okay, so each one of these is powered by the power on the outside. So a power to a power, and we multiply. So 1 times n would be n. So x to the n. Y to the 1 to the n, 1 times n is n. So we have x to the n, y to the n. Everything inside has to be multiplied by the power on the outside. Okay, so if you have 2/3 to the 4th power, 2 is to the 4th power, 3 is to the 4th power. Okay, and then you can put that in your calculator. 2 to the 4th is 16, 3 to the 4th is 81. So when you take a power of a quotient, you apply the exponent to all the parts of the quotient. So again, the quotient law is where you have two bases. Each, the numerator and the denominator, each have to get the power of n. All right, number 7. So law number 7 is negative laws of exponents. If the base is powered by the negative exponent, then the base becomes a reciprocal with a positive exponent. Basically what that says is we can't have negative exponents. So if we have a negative exponent, we are going to take the base and move it from the numerator to the denominator and make the exponent positive. Now you should also know that when we take 5 to the negative 3rd, which is in the numerator, and move it to the denominator and make the exponent positive, we put a 1 over the top of it in the numerator. Now, if it's negative in the denominator, basically what we do is we move it back up to the numerator and make the exponent positive. Okay, so it's basically a switcheroo. If you have a negative exponent in the numerator, put it in the denominator, make the base positive. If you have it in the denominator, negative in the denominator, you put the back up into the numerator and make the exponent positive. Now, this is only the exponent. It has nothing to do with if the 5 was negative. If the 5 was negative, we would not change the sign of the base. Okay? We only change the exponent. So please keep that in mind. So when I have a negative exponent, I switch the base to its reciprocal with a positive exponent. If the base with the negative exponent is in the denominator, it moves to the numerator to lose its negative sign. All right. Law number 8 is the zero law of exponents. Any base powered by a zero exponent always equals 1. So if I have x to the 0 power, I have 1. If I have 5 to the 0 power, I have 1. If I have a to the 0 power, I have 1. If I have more than one thing to the 0 power, it is also 1. So 0 factors of a base always equal 1. Every power has a coefficient of 1. Okay. Excuse me, let's do a couple of examples. So we have a whole bunch of stuff to the negative third power. What I do is I go ahead and take care of the power to the power. So the power on the 2, or the exponent on the 2, is a 1. So I'm going to give everything the power of negative 3. A power to a power, and we multiply. So 2 to the negative third power, x to the 6th power, negative 2 times negative 3 is 6, y to the negative 12th power, and 0 times negative 3 would be 0. Now, if we have negative exponents, then we will move the negative exponents down below. So 2 to the negative third goes in the bottom, and it becomes a positive 3. X to the 6 stays on top, y to the negative 12 goes on bottom, and z to the 0, guess what? That makes a 1. So anything to the 0 power is 1. So then the answer to this problem would be x to the 6 over 8 y to the 12th, because 2 to the 3rd would be 8. Okay, let's try this one. I have this product and I have this product, and these two things are being multiplied. So what I'm going to do is I'm going to take 5 times 2, which is 10. I have x to the 2nd, x to the 3rd. That means I have 2 x's over here and 3 over here for a total of 5. And then I have negative 8y's and positive 5y's, which would make a negative 3y. And then I can't have negative, so I would have 10x to the 5th over y to the positive 3. Okay, that's just a couple of examples of how we use those exponent rules. We will come back and practice more tomorrow.